Good morning, student. This is Duryodhana Dalai, lecturer in mathematics, Government Degree College, Paderu. Today we will discuss about bounded sequence. First, we see the definition. First, we see what is the range of a sequence. Roughly speaking, range of a sequence is a collecting all terms of the sequence in a set form. Formal definition, let's see. Let A and B a sequence of real numbers. The range of the sequence an is defined as range is equal to set an such that n belongs to n. Let us see some examples. Take a constant sequence. An is equal to constant, where k belongs to real number. What is a1 first term? A1 is equal to k. What about second term? A2 is also k. Similarly, a3 also constant k. an is also k. So the range of the sequence containing only one term, that is singleton k. Now come to another example. Consider the sequence -1 whole power n. Put n is equal to 1. We will get the first term. a1 is equal to -1 whole power n, that is -1. How we will get the second term? a2 in the place of n, put n is equal to 2. So -1 whole square is equal to nothing but 1. Generally, if n is odd, then -1 whole power n is equal to -1. If n is even, then -1 whole power n is equal to +1. So the range of the sequence containing only two terms, that is 1 and -1. So range is the set containing the elements 1 comma -1. Okay, come to another example. The range of, consider the sequence 1 plus -1 whole power n. If n is odd, then 1 plus -1 whole power n is equal to 1 minus 1, that is equal to 0. If n is even, then 1 plus -1 whole power n, that is equal to 1 plus 1, it is equal to 2. So the range of the sequence containing two terms, one is 0, another one is 2. So range of the sequence is the set containing two elements 0 comma 2. So what about the range of the sequence n? You put a1, then that is equal to, first term is 1, a2 that is equal to 2, a3 3, so n. Nth term is n. So 1 2 3 dash, that is the range of the sequence is natural number set. Now come to the, what are the bounded below sequence? A sequence n of real numbers is called bounded below sequence if all the terms of the sequence are right to some real numbers. All the terms are must be right to some real numbers. Formal definition. There exists a m belongs to R such that m must be less than or equal to an for all n belongs to S. All R should be left of an. Another definition is there. A sequence n of real numbers is called bounded below sequence if the range of the sequence should be a bounded below subset of real numbers. The range of the sequence must be a bounded below subset of R. Now come to what is a bounded above sequence. A sequence n of real numbers is called bounded above sequence if all the terms of the sequence are left of some real numbers. Those are all to left of some real numbers. Formal definition. Let m belongs to R if there exists a m belongs to R such that an less than or equal to m for all n belongs to n. All numbers should be left of m. All the terms of n should be left of m in the real line. We have another definition. A sequence n of real numbers is called bounded above sequence of real numbers if the range of the sequence should be a bounded above subset. It should be a bounded above subset or subset of R. Now come to what is a bounded sequences. We have so many definitions here. Bounded sequence. A sequence n of real numbers is called bounded sequence if the range of the sequence is a bounded subset of R. Bounded subset of R means the subset of R must be bounded below subset as well as bounded above subsets. All the numbers of the subset must be left of some real number is right of some real number. Definition 2. A sequence n of real numbers is called bounded if it must have lower bound as well as upper bound. Same definition. It should be have a lower bound as well as upper bound. Then you say that the sequence is a bounded sequence. Come to another definition. A sequence n of real numbers is called a bounded sequence if there is a small m and capital M belongs to R such that m less than or equal to n less than or equal to capital M for all n belongs to n. This means all the terms of the sequence n must be lie between small and capital M. All the terms should be lie between m and capital M, where m comma small m some real numbers. Then you say that this sequence is a bounded sequence. That can also modified. Definition 4, the same definition can be modified like this also. A sequence n of real numbers is called a bounded sequence if there exists a m belongs to R plus. R plus means set of positive real numbers which are all more than 0 such that the modulus of an is less than or equal to m for all n belongs to n. This is the same definition. Now come to some examples. All constant sequences are bounded. Why all constant sequences are bounded? Because range of the constant sequence is just nothing but singleton set. We know a singleton set is a bounded set in real numbers. The number itself is bounded above, the number itself is bounded below. Consider another example, -1 whole power n. Here the range of the sequence is, if n is odd, it gives a -1. If n is even, it gives a +1. So range of the sequence is 1 comma -1. We know the set is a finite set. 1 comma -1 is a finite set in real numbers. We know that the range set is a bounded set in real numbers. So the range of the sequence is bounded. So this sequence is a bounded sequence. See, when you say that sequence is bounded sequence, the range should be a bounded subset in real numbers. Consider another example. The sequence -1 by n is I will say that it is a bounded sequence. How? Let's see. Here -1 by n is positive, so all are less than 0. All numbers are less than 0. Look, it has a upper bound. The set has a upper bound. Put n is equal to 1, this becomes -1. Put n is equal to 2, this becomes -1 by 2, increasing. Put n is equal to 3, it gives -1 by 3. N is equal to 4, -1 by 4. It's going on. All are bounded below by -1. So all the terms of the sequence are lie between -1 comma 0. All are lie between -1 and 0. -1 is the lower bound, 0 is the upper bound. So the range of the sequence is bounded subset of R. So this sequence is a bounded sequence. See, I am repeating the term. Bounded sequence means range of the sequence should be a bounded subset of R. Consider another example, my 1 by 2 power n. Put n is equal to 1. The first term is 1 by 2. Put n is equal to 2. The second term is 1 by 2 square, that is 1 by 4. It is decreasing. Put n is equal to 3. Is gives 1 by 2 cube, that is 1 by 8, decreasing. All are decreasing. So all terms here positive terms. So all are 0 less than or equal to 1 by 2 power n. 0 is lower bound here because all are greater than or equal to 0. This means 0 less than or equal to all the terms of the sequence, and it is bounded by 1 by 2. Upper bound is 1 by 2. So all the terms of the sequence are lie between 0 and 1 by 2. So the range of the sequence is bounded subset of R. So this sequence is a bounded sequence. Now consider another example, 1 plus 1 by n whole power n. See, we know that here all the terms are lie between 2 and 3. Here the sequence 1 plus 1 by n whole power n all are lie between 2 and 3. Put n is equal to 1. This gives a 1 plus 1 whole power 1, that is 2. It gives a 2. And we know limit of this sequence is limit 1 plus 1 by n whole power n is equal to e. E value is 2.718. Here all the terms of the sequence are lie between 2 and 3. So the range of the sequence is a bounded subset of R. So this sequence is a bounded sequence. Note that all bounded sequences are not a constant sequence. Take the second example here, minus 1 over power n. Where n is odd, it gives minus 1, n is even, it gives 1. It is not a, even though it is a bounded sequence, but not a constant sequence. This sequence is not a constant sequence. So these are all about bounded sequence. Okay, thank you very much.